All right, welcome to Chapter 7 on annuities and mortgages. In this chapter, the first thing we'll need to do is understand simple interest and compound interest. So away we go. It's the last chapter we're going to cover this year, so let's get after it. So simple interest is just the money earned on a starting principal. It's I equals P times R times T. I is the interest earned in dollars, the amount of interest. P is the principal that you invested originally. R should be lowercase r is the interest rate as a decimal. T is the time in years. Again, it's a lowercase t in years. Very simple calculation to make. Mike invests $3,000 for 3 years at 6% simple interest. How much interest does he earn? Just go I equals PRT. Principal he invested originally was $3,000. The interest rate is 6%. I need that in decimal. Take the percentage, divide by 100, and you'll find it's 0.06 times the time is 3 years. This color scheme is already annoying me, so we're going to switch it to black. And I'm going to punch that into my calculator real quick. I got 3,000.06 and 3. Gives me $540 of interest. So now your investment's worth, $3,540. Compound interest is a little more complicated, but it's more realistic to what a real world investment, how it will behave. It's money earned on the principal and previous interest earned. So this one gives you the amount that your investment is worth. That's what A is. So it's A equals P times 1 plus interest to the power of N. A is the amount in dollars that your investment's worth. P is the original amount of money you put into the investment. I is the interest rate per compounding period. And N is the total number of compounding periods. Some of those, if it's been a while since you've done a calculation like that, are tricky, but hopefully this example will clear it up. Same guy, Mike, same money, $3,000, same time, 3 years, same percentage, 6% per year. But now it's going to be compounded quarterly instead of simple interest. How much interest does he earn? So now the formula is A equals the principal times 1 plus the interest to the power of N. So there's the formula. Starts out simple enough. If you got your 3,000, you've got your 1, and calculating what the interest now it's still divided by 100, so it's 0.06. But then you have to divide that by the number of compounding periods per year. So quarterly means 4 times per year. So I have to divide 0.06 divided by 4, and it's 0.015. So I put that in there, 0.015. And now the total number of periods, it's 3 years times 4 times per year because it's quarterly. So that equals 12 compounding periods. Now in my calculator, I'm going to type 3,000. I'm going to do all this in one step, times bracket 1 plus 0.015. And then I'm going to hit that exponent button. It's that on my calculator. Some people, it's y to the power of x. And to the power of 12, and that's going to give me my answer. So here we go, 3,000 times bracket 1 plus 0.015, close my bracket, to the power of 12, and it gives me 3,586.85. So that doesn't tell me how much interest is earned. That tells me how much money my investment is worth now. So the amount of interest that I earned is equal to, well, that new amount minus my original investment. So that's going to be $586.85. As you can see, with the same money and same interest rate, you get a little bit more money out of compound interest. And the longer you let your investment sit, 540 versus what was it, 586.85. It's actually quite a large amount in just 3 years for a reasonably small investment. The one other type of calculation you'll have to be able to do today is, what if you need $25,000 to, I don't know, pay for your education, buy a car, I don't know what you'll be up to, and you need it 10 years from now. the bank pays 5% compounded semi-annually. So let's calculate some of our things beforehand. Now, it's the same formula. I'm going to be using A equals P times 1 plus the interest rate to the power of n. So let's figure out what n is first of all. N is the number of compounding periods. 10 years semi-annually. Semi-annually means twice a year. So 10 years twice a year, I'll just go 2 times 10 equals 20. There, that number is locked down. You know, I can start putting in well, P is what we're going to try and solve for here. Let me restart this. So what makes this question different is I need $25,000. I want to know how much I got to put into an investment now so that I get $25,000 in 10 years. So over here, I'm going to have 1 plus the interest rate to the power of, now I know it's 20. Now, what about that interest rate? It's 5%, which is 0.05 in decimal, divided by how many times do I compound it per year? 2 times per year. So it's 0.05 divided by 2, which is 0.025. So that's what goes here, 0.025. And now I just have to solve this thing. Now, if I just calculate that out, it'll give me this a decimal, and I can divide 25,000 by it. That's probably the easiest way to do it. Now, I'm going to have to take this whole big chunk 1 plus 0.025 to the power of 20 and divide it over by 25,000. So that's what I'm going to do. P times, and I'm going to work all that out. 1.025 to the power of 20. And I'm going to keep that number in my calculator because it's more decimals than I'd care to write out right now. 3, it's 8, 6, and then there's some other stuff. But keep that number in your calculator. And then I got 25,000 over here. Because we're going to want to divide 25,000 by that. So I'm going to take 25,000, I'm going to divide it by this number over here. And an original principal of 15,256.77. So I need to invest for those 10 years of just over $15,000 if I want $25,000 in 10 years. And you might think, well, that's too much to invest right off the bat. But, you could be contributing to this over time. If you just want to just put in a lump sum, do absolutely nothing, don't put any more money in the bank, then you would have to invest $15,000 if you want $25,000 in 10 years is the way that you would do that. Alternate solutions to this would be if you take that exponent 20, just to show you over here, 25,000 equals P times 1.025 to the power of 20. So if I move this whole chunk to the other side of the equal sign, I can write that as 25,000 times 1.025 to the power of negative 20, which is actually the way I didn't tell you guys, but that's the way I typed it into my calculator. When you move that over, it becomes a negative exponent, and that's the way it works. So if you type that into your calculator, if you type in 25,000 times 1.025 to the power of negative 20, then it should work out for you, okay? So that's it. That's the bulk of what you're going to have to answer. These are the 2 pages you're going to work out of. You can see I ripped off a question, I think here. Yeah, the 586, that compound interest question I took from there. But the rest of these questions to solve should be new to you. So I want you to do number 1, 2, and 3 on this page, and number 1 and 2 on that page. And that's it. Just messing around with simple and compound interest, and then the toughest one is that last one when you're trying to find the principal. And if you didn't think my example was good enough, here they do have one right here on page 407, it's basically the same thing that I did, just some different numbers if you'd like to see another one. So he wants to have 6,500 in 3 years, compounded semi-annually, just like the one I had, and 4.6% interest rate. And you just just try and follow what they did. Anyway, I think that's it for now, guys. In the post, I have put what I want you guys to do. So the 1 to 3 and the 1 to 2, attach a picture of your work like you've been doing and hand it in, and that would be just great, guys. Good luck with all that. Keep the emails coming and comments on Google Classroom if you're struggling with any of these. I'm happy to answer any questions that you have. All right. Good luck.